Dear student, today we are learning about something called the average rate of change. It tells us how much a function's output, the y value, changes on average for every 1 unit change in the input, the x value. So let's go to the first question. So let's find the average rate of change between two x values using the formula step by step. So we have the first function. So from 0 to 3. So substitute each x value into fx. So when f0, 9 minus 0 square, which is 9, f3, 9 minus 3 square, which is 0. Then we apply the formula. Average rate of change is 0 minus 9 over 3, which is negative 3. So we know that this is fx2, and then this is x2. This is fx1, this is x1. So we just substitute everything. The function decreases on average by 3 units for 1 increase in x. So you can see this negative value decrease. So next for b, substitute f negative 1, 9 minus 1 square, which is 8, f5, which is 9 minus 25, which is negative 16. So substitute f5 minus f minus 1 over 5 minus 1, which is negative 20, which is negative 16 minus 8 over 6, which is negative 24 over 6, which is negative 4. So it is, the function drops by 4 units per 1 unit increase in x, so it also decreases a negative value. Next, we want to see, substitute f negative 2, 9 minus 4, which is 5, f2, 9 minus 4, which is 5. Next, the formula says that 2 minus 2. 5 minus 5 over 4, which is 0. So the function did not change average. It started and ended at the same height, so the graph was flat on average between those 2 points. So we go to number 2 next. Question 2 given a table and then ask us to find the average change between the following points. So if you see negative 3 to 1. So f1 minus f minus 3 over 1 minus 3. So f1 the output is 3. So we put in 3 minus 7 over 4, which is minus 4 over 4 is minus 1. And then we know that the function's output decreases by 1 unit. Decrease. Next, f4 minus f0 over 4 minus 0. So we need to go through what is the output. f4 is minus 8, f0 is minus 2. Okay, so minus 8 minus 2 over 4 minus 0. Then it is minus 8 plus 2 over 4. It is minus 6 over 4 and it is minus 33 over 2. So the function also decreases on average by 1.5 unit for each one increase in x. Okay, so from number 1 and number 2, we know that the average rate of change tells us how much the function rises or falls on average between 2 points. A positive rate meaning it's increasing. A negative rate means it's decreasing. A zero rate means it stays flat overall. Next, number 3, we read the points from the graph. So I have f -6. -6 will be here, 2, 4, 6. This is -6, so our output will be 1. F4, 4 is here, x4 is here, we go up to find the y value, which is 3. So this is 4 and 3, this is -1 and -6 and 1. So my output here is 3. Then we substitute in the formula. So f4 minus f minus 6 over 4 minus 6, which is 3 minus 1 over 4 minus 6. Okay, it is 2 over 10, which is 1 over 5. Okay, next we move on. So this is positive, right? So it function increases slightly. Okay, so next, f -2 is -3, f2 is -1, then you substitute in the formula. Which is 1 over 2. So here also, increase, the average rate of change is 1/2, means it is rises gently.
Now we'll apply what we learned about average rate of change to a real life situation, a basketball game. The table shows how many total points the Arlington's girls team had scored after different times in the game. The time T is in minutes and FT is the total point score. So we'll find quickly they were scoring. That means how many points they scored on average per minute. So for A, average rate in the first half of the game. So we use our formula, average rate of change is equal to ft2 minus ft1 over t2 minus t1. So first half meaning that our t is equal to 0, t1 to t2 is 16. Okay, so we plug in f16 minus f0 over 16 minus 0. F16 from the graph here is, our output is 48, and then F0 is 0. So it is 3. So 3 points per minute. That means in the first half, they score an average of 3 points for every minute of play. Then the average rate over the whole game. Whole game, we know that our T1 will be 0, T2 will be 32. Right? So I will use the same formula. So it will be F32 minus F0 over 32 minus 0, which is F32, our output 32 is, output for X32 is 64 minus 0 over 32 minus 0, which is 2. So 2 points per minute. So for the entire game, they average 2 points every minute. Then for C, given your answer above, which half of the game do you feel they had a better rate of scoring? Explain. So we can see that 3 points per minute is faster than 2 points per minute. This means that they were scoring more quickly in the first half than in the second half. The first half had a better scoring rate because they averaged 3 points per minute compared to only 2 points per minute for the whole game. So answer should be, we know that 0 to 16 minutes, it is The average rate is 3 points per minute, and then meaning that faster scoring, good performance. So for the whole game, 0 to 32 minutes, it is 2 points per minute. So slower scoring overall. So I will choose the first half, the first line. And average rate of change isn't just for graph, it helps describe real performance too. In this case, the rate tells us how quickly points will be scored per minute. Okay, then number 5. For number 5, it gives us this function and asks us to find the average rate for x1 to x5. So we find f1 is 6, 1 plus 5, which is 11. For f5, the output for it is 6 times 5 plus 5, which is 35. So we substitute it inside our formula, f5 minus f1 over 5 minus 1, which is 35 minus 11 over 4, which is 6. So for the A, average rate of change is equal to 6, means that the function increases by 6 units every time x increases by 1. Okay, so for B, we need to find for this x negative 2 to x equals 6. So we find first negative 2. What is the output? So we put in x to negative 2. It is negative 7. For f6, it is 6 plus 5, which is 41. So we put in inside the formula f6 minus f negative 2 over 6 minus negative 2, which gives us 41 minus 7 over 41, over 6 over 8. Okay, it will give us 6. It means that average rate of change is equal to 6. So next, C, what does this tell us? So since we got the same answer for both example, A and B, we got 6. Answer is 6. It's constant, always 6. That means function rate of change never changes. This tells us the graph is a straight line and the number 6, its slope. So only linear function have average rates of change that are constant. This is a linear functions. In this case, the average rate of change is the slope of the line. In the case of a linear function, we call its average rate of change its slope. Thank you for today.